Here we go. All right, so ladies and gentlemen, let's say we are given this function, okay? I'm just going to do super quick, simple example. But let's say I want to integrate 4 over x dx, okay? So as I'm looking at this, you see, if you made this x a power of -1, what would happen if I added 1 to -1? What would we get? 0. So that's why we can't use that power rule. We have to start understanding that if I have something to a -1 power and I add 1, that would give me 0, therefore it wouldn't exist. But we know this not to be true. So, okay. So what I'm going to do is I'm going to rewrite this. I'm going to say it's 4. I'm going to integrate 1 over x dx. Okay? Now we've got to think about this backwards. If natural log of x is equal to the derivative of 1 over x, if I integrate 1 over x, it's just going to give me natural log of x. So here I would have natural log. Now I have to put absolute value of x. And I'm going to put the 4 on the outside because that's just the coefficient. Just stays outside. And then because we are integrating, we've got to bring in back c. But you bring in that constant of integration to be absolute. Okay? Now, how else could I also write this? Because it's not going to look like this. Yeah, it's going to look like natural log x to the 4th plus c. However, you notice, why don't I have absolute value bars there anymore? Exactly. Because this power of 4 will automatically make anything you plug in a positive. So look out for that as well. We have to understand our odd and our even powers and what they do to those variables. Okay?
So if you had power of 3, you would solve them out.
Exactly. Okay? All right. So let's move on to something a little bit trickier because nothing's ever going to be that nice for us. Okay, example 1. So I'm going to be integrating 1 over 4x minus 1 dx. And as I look at this, guys, okay, like I have a coefficient with my x, I have a minus 1. You guys kind of see how it's kind of ugly, right? So, I have to use u substitution. Okay? In this case, what do I want to make my u? Yeah, exactly. I want to take care of that entire denominator. So if u equals 4x minus 1, let's go through the process. That means du will be equal to 4 dx. Okay, kind of looking familiar? And then as I go back, I can take care of this 4x minus 1 with that u. dx can almost be taken care of if I do what? Divide by 4. So I have 1/4 du equals dx. Okay? So that means when you're integrating, you really have 1 over u times 1 over 4 du. And if you want to, what can we do with that 1/4? Because it's just, yeah, we're going to move it out. So I'm going to say 1 over 4 integral 1 over u is now really nice because I have just that 1 over u, right? So when you integrate, 1/4 natural log absolute value of u plus c. However, bring it back in. What does u stand for? So plug that back in. Now I would have 1 over 4 natural log still absolute value of 4x minus 1 because I don't know what x is, plus c. And you could check this work, you could take a derivative and you would find that you end up right back here. Okay? Kind of okay? Yeah? Okay. So that was unbounded. Let's look at something that is bounded. So I'm even going to put like bounded integral. So here's my integral. We're going to go from 0 to 3. I'm going to make it the function of x all over x squared plus 1 dx. I know. All right. So as we're looking at this, you're all like, oh, I don't know how to do a quotient rule, right? Like I kept telling you guys, we don't know how to do an integrated quotient rule. This is why it's good to use substitution, because we're going to make u our, what are we going to make u? X squared plus 1. So if u equals x squared plus 1, take the derivative. The derivative is going to be du equals 2x dx. And as you can kind of see, it's going to take care of some things for us, right? So what should I do over here so that it takes care of it pretty nicely? Yeah, divide by 2. So I'll have 1/2 du equals x dx. So now let's go through. Leave it unbounded for a second, okay? Leave it unbounded. So I'm going to have 1 over u. This x dx is going to be replaced by 1/2 du. Now, why did I say to leave it unbounded for a second? So I can do what with it? Because I'm changing these to u's, let's change our x values to u bounds as well. Okay? That slight trick that we kind of forget. So if I take 0 and plug it in for this x down here, what's your new u value? This is going to be 1 down here. Okay? If I take this... What do you think it was?
I don't know why I thought it was an E. And I was like, it's an E.
Okay. If I take 3 and I plug in 3 squared will be 9 plus 1, so my new upper bound is 10. Okay? So again, maybe you want to bring that 1/2 out before we integrate. Now, ladies and gentlemen, I am seeing this, and they will mark you wrong, okay? You have to understand, when did you integrate? Because once you integrate, that integral sign has to disappear. You have to show a clear understanding of having a derivative and going back to its function. And if you put the integral sign throughout the entire problem, you're not sure when that happened. Do you know what I'm saying there? So, as I go through and integrate, notice I just keep the 1/2. I'm integrating. This 1 over u will just be natural log absolute value of u. Do I need the plus c? No, because I am bounded. So this is 10, this is 1. What do we do from here? Huh? We're not. We changed our bounds for a reason. We're just going to plug in our upper bound, subtract our lower bound. Okay? So equals 1/2 natural log absolute value of 10 minus natural log absolute value of 1. In this case, we got lucky because both of them were positive. But which of those do I know the value of? Yeah, natural log of 1 is just 0. So what you really have is you have 1/2 natural log of 10. Or if you really wanted to get fancy, natural log square root of 10.
Radical, dude.
Okay. So, are we okay with that jump from here to here? Okay. This is probably how it would appear on a test or an AP response. Okay? I mean, I got it. I just didn't laugh.
So they don't have, if we don't laugh, they don't have to be in the absolute value sign anymore?
Okay, so that's a good question. She's asking, do they have to be in the absolute value signs if they're positive? Well, you can take the absolute value of it. It just happened to be the same result. Does that make sense? Okay. So, like, if I had, like, for instance, -3 and -2, when I plug them in, it would have to be the absolute value of -2 to get 2, minus the absolute value of -3 to get 3. I'm saying whatever's in here, they're there because your domain cannot be negative. Okay? Okay. All right. Example 3, we're going to go back to an unbounded, guys. All right, here we go. You're going to look at it, you're going to think it's ugly, and then you're going to be like, oh, no big deal. Alright, so in this case, the common trend for today's note seems to be what? U substitution where? With your denominator, okay? So let U equal x cubed plus x, right? Take a derivative, again. What's our derivative going to be? Plus 1 dx. So again, it looks really ugly, but it's meant to, okay? So, if I'm going to go plug everything in, I understand that that's going to be 1 over u, and then 3x squared plus 1 dx is taken care of with just du. We can go ahead and integrate. So it's just 1 over u. So when I integrate, I don't need an integral sign anymore. I'm going to have natural log, absolute value of u, plus c because it's unbounded. Do I have to plug my x's back in? Yes. So natural log, absolute value of x cubed plus x plus c. Do I need the absolute value signs here? Yes. Okay. We do. Okay. Oh. And then let's get to where Malcolm was mad at me yesterday. Okay? Well, I mean, life, but yeah. Okay. Okay. Ready? Okay. Example 4. I'm asking you guys to remember some algebra / pre-algebra skills here. I know, right?
Oh, those were 10 years ago now.
10 years ago?
Before the war.
Back in my day. Back before now.
Okay. You can't even see it, which is what's great. Okay. So, ladies and gentlemen, I am asking you to remember some stuff that you may or may not remember. So, okay. So, just as a quick, little test here. 5 over 4. Can you give me 2 fractions that are equivalent to 5 over 4 when you add them?
Wait a minute. Whoa.
Okay.
Too fast, I wasn't ready.
Well, look at the example. Maybe you can give me another one.
Anthony's got the 4.
I got you. 4 plus 1.
Mm-hmm.
Stop spinning. That's fine. Yeah.
Or 6 over 4 and negative 1 over 4. Whoa, hold the phone. I went negative on you. But yeah, do you guys agree, these are equivalent?
Yeah.
Okay. So, all I did is I took this fraction and I broke it up into 2 fractions that made that fraction. Yeah, whatever he just said, because I didn't know the word.
Oh, you
Okay?
can factor it and then split it up.
Fractal decomposition. You guys would have done a little bit of in pre-calc with the numbers like this, but this is like a pre-algebra skill, right? Like, we understand that. So watch what's going to happen. I'm not changing the problem. I'm just rearranging it. Maybe.
How do you work it out?
I mean, that was the precursor, right?
That's where she was going with it.
Okay. So let's think. Did I keep the same denominator?
Yeah.
Yeah. Do I still have an x squared being added with x being added with 1?
Yeah.
Yeah, because I have that common denominator. I could break it up. I could make these 3 different fractions if I really wanted to. I don't want to. But I haven't done anything illegal. So what's the purpose of this? Why is this so nice? Yeah, this is just going to end up being 1. And then I'm going to add the second integral of x squared plus 1 dx. Again, I'm allowed to do this. Correct? So if I integrate 1, what is that going to be? Okay, so that one's simple. We could just get x in this first integral, right? But then as we look at the second integral, we notice, okay, that's where the new stuff's coming in. Because you should let what? Yep. U equal x squared plus 1, because du will then equal 2x dx, which almost helps me if I do what? Divide by 2. And there's a reason I skipped a line here, because I understood this integral right away. Okay? Here, I'm just going to kind of put a plus, like, I'm going to bring that 1/2 out front right away. I'm going to integrate 1 over u du. You guys are okay so far? Okay. So then let's bring it back. So plus 1/2, if I integrate 1 over u, is just going to be natural log absolute value u plus c. Now, here's where I have a problem. I can't have x's and u's in the same statement. So what should it be? Should it be in x's or should it be in terms of u? It should be in terms of x's. It always should be in terms of x's. The only reason we're using u, okay, it's like that breakup person right after you get out of a relationship. Like you're using somebody, okay? We're using the u. Yeah, the u is the rebound, okay? We're just using it to help us move on, okay? Maybe you are going back to your ex, okay? So we're using the u and going back to the x, okay? Now, I have x plus 1/2 natural log. Let's even remember what u stood for. So absolute value x squared plus 1. The question is, do I need the absolute value?
Oh, no, because it's squared.
We don't need it. Because since it's a square, no matter what value you put in here, that outcome will always be positive. So, this is how it would look. X plus natural log square root x squared plus 1 plus c. That's probably how you would see it. Okay? All right, and then the last one for today, so you guys can get a jump start on that homework.
I mean, you don't mark it wrong, though, because that's the
No. In fact, homework took me a long time to grade, to go through last night, because I'm just like, oh, this is right, but it doesn't look like mine. And I'm going to go over number 9, by the way.
Thank you. There's extra credit, right? So if you didn't mark it wrong.
Did I put extra credit on the thing?
No one did it.
Well, I have to go back and change all the grades now. I didn't realize I put it as extra credit. Okay? Except for, I had 2 people who actually got it. So, maybe 3. Maybe 3. You did pop into my head right away, so I don't remember. Okay, so example 5. I was even thinking I was doing this like, man, 9 is kind of like bad. Like, it's just long and tedious, but yeah. It was. Okay. Coming from the one student who didn't turn in the homework.
We should still do number 9.
Roasted.
Okay, so, here we go. There it is. How you guys feel about that? Okay, so we gotta think. Let u be x plus 1. Okay.
I don't know how to feel about this. Doesn't work.
What do you mean it doesn't work? It has to work. There has to be some physical way to do this.
Why do you think it doesn't work before you figure out what?
That's what happens when I don't understand.
So, Anthony says it doesn't work. Why are you saying it doesn't work? Because du happens to equal 1 dx, right? Okay. It takes care of dx. How quickly you guys forget. You have to solve for x. Let's not forget that we can do that. So I can have u minus 1 also equal x. Okay? Now, what I'm going to do is I'm going to plug in all this information to see what it gives me next. Okay? So I'm going to plug this in. I'm going to get integral 2 times u minus 1, because that's what x is, all over u squared, and that 1 dx can take care of du. Okay. So let's think about what I really have. What can I do with this 2? I can distribute it. It could be 2u minus 2, right? Has that helped me yet? Not yet. But using that little trick that I had up above, what can I do? I can separate them. Okay. Are we seeing anything? So these u's can simplify, and I'll end up with just 2 over u du minus, what's wrong with the next one? That's u squared. Oh, but it's not u to the first, right? So let's just make it 2u to the negative 2. If it was u to the first in the denominator, then I would use natural log, but since it's not to the first, it's to the negative second, and I can apply that anti-power rule. Okay, let's not forget about the rules we supposedly already remember, or already know, right? So, let's go back and let's integrate. Again, I haven't done any integration yet, I'm just setting this problem up. So I'm going to have 2 natural log absolute value of u. We're good on that? Minus 2 u to the negative first. I'm going to bring that power down times 1 over negative 1, which is negative 1, plus c. Again, because it's unbounded, I can't leave these in terms of u's. I have to plug in the x. So 2 natural log absolute value, x plus 1, absolute value, plus 2 all over x plus 1 plus c. Yeah?
In this case, it doesn't matter because it ends up the same thing, but you're supposed to divide by negative 1.
I said that. I said 1 divided by negative 1 is negative 1.
Oh, fine. Thank you.
It's okay. You can go back and watch it later. But if you saw it, it might be looking like this. Okay? And that's your final answer. So like I said, I'm breaking apart notes. That's all we're doing for today. Monday, we're going to finish it off with, we're going to have to do trig.